Advanced math, one more advanced percent problem strategy for you today, and that is tables, one of my favorites. They really help me think about problems and not kind of worry about being right, but just sort of like try and make mistakes in a way that's productive toward getting me where I want to go and not feeling obligated to be kind of right the very first time. So I like it a lot, and we're going to do that today. So make this the title on the next page in your math notebook, and then when you're done, put your pencil in, close it up until we get to the we do. So we've been solving the same problems for a few days. I like to, a lot of times using the same problems, and I want to get rid of this part. We didn't need that. Solving the same problems with different strategies is helpful. So we've looked at solving this so far with tape diagrams. And in that case, we kind of made the tape, said, okay, tape diagrams, tapes usually represent 100%. And we said, so that 100% of the price, the whole price, that's like the original price, which is $22.50, because in a tape diagram, the whole tape has to represent the whole. There's two parts, right? There's sort of like the part you pay, which was the $13.50, and the part you saved, which I believe was $9 if you calculate that, minus $9. And then we used the tape diagram from there, and we kind of figured out we could cut this into 2 and this into 3, and then all the pieces would be the same. They'd each be $4.50. We also solved this with ratios. And we kind of said, okay, well, we're going to save a certain amount of the price. So we said, what percent, that's what we're looking for. What out of 100, we know we're going to save $9, is the same as saving $9 out of $22.50. So we made a ratio where it was sort of saved on the top, the amount saved, and the whole on the bottom. So the percent saved out of 100 equals the money saved out of the total price. And we also solved that using decimals, saying sort of, what decimal, x times the whole price is going to equal $13.50. So like, what percent of $22.50 is $13.50? And there we ended up with a nice decimal and say it was like 60%, which means we saved 40%. So that's kind of how we have done it before today. Today I just want to solve this with the idea of a table. A lot of times when I use these tables, these tables, if you're not recognizing my wording, like this, what I really like about this is it's sort of like trial and error. Like, I'm just going to make a guess, a trial, and kind of see if it's right. I may need 3 columns for this one. Here's how I'm going to kind of think about it and say, okay, well, if the original price is $22.50 and I do the percent off, then, what will be my discounted price? So basically what I'm going to do is just guess and say, okay, well, let's just see. Like, for starters, I can see this is, I know I'm not saving half of the price. So no, it's less than that. So I'm just going to take a stab and say, okay, maybe it's 25% off. Let's just see if that's right. Maybe I'll get it right on the first chance. So if I am 25% off, that means I'm going to pay 75% of the price. And let's just see if I'm right. Let me pull up my calculator here. And say, okay, well, what is 75% of $22.50? 75% of times $22.50 would mean the new price is $16.87 or $16.88. It's not. So that's not it. So I'll try another one. So I need, look, I didn't get down far enough, so I need to save more. So maybe it's 30%. I'm just going to try it again. If I save 30% off, that means I pay 70. And let's try that. So 70, let me clear. 70% of 2250 is 1575. Not right. Gotta save more, and I can just keep trying. I know we know the answer to this because we've done it. And I can just say, okay, well, I gotta do a little more. A little more, a little more. And of course, I can keep trying until I get to the right number. Say, okay, well, what if it's 40% off? That means I'm paying 60% of the price. And 60% of 2250 is, of course, 1350. So I kind of use that table, and I just use it as a way to just guess my way to the answer. I mean, I hate to say guess because guess makes it seem like you have no idea. And I used a lot of common sense there. I just kind of kept increasing my percent till I got there. But that's really how it is like, rather than just calculating the right answer, I'm just going to work my way toward it. All right, open your notebook. Let's try one together. Let's work on these chessboards and chess sets. So, 20% more chess sets than board games. So this is a tricky one. I might need a lot of columns here, so I'm kind of thinking about, let's see, which one's less? 20% more chess sets. So I'm going to do the lower number first here. So let's say board games, chess sets, and total. And what I'm going to remember is I'm saying, okay, I'm doing 20% more chess sets, right? So that actually in math, the way I do add 20% more is it's sort of like I do multiply by 120%. Right? It's like I have all those plus another 20%, if you remember that strategy. That gives us the amount of chess sets. I'm going to keep multiplying by there, and I want to make sure I got 66. So like, here we go. So I just say, okay, 66 total, 20% more. Let's take a stab. Let's try it. What if the number of board games was 20? Just come out of nowhere. So 20% more, if you think of, if you don't want to do the multiply by 1 and 20% means like 5 groups. So that'd be 4, 4, 4, 4, 4. So 20% more would be another 4, right? That'd be like 100, the 20% over 100. And I'll verify that with a calculator. 20 times all of them and 20% is 4 more. So 24. Which means if I did that all together, I would have sold 44. Not even close. I need 66. Right? So I need way more. So maybe I'll go up to like, I don't know, 25. So if I try 25 times, I don't know why it's way over there, 120%, 20% more, that's 30. And altogether that is 55 sets. Getting closer, but not really there. Let's keep increasing. So you guys, I know we've done this one, so I think you already know the answer. But it's totally fine if you overshoot. And when I say, that's still not very close. I don't seem to be accelerating quickly enough. Maybe it's like 35. So if they do 35 board games times 120%, then it's 42 chess sets. And let's see, that's 77 total. That's too high. I went too far. I only need 66. So logic would tell me don't keep increasing this because I'm already up too high. So 25 was too low, 35 was too high. So it seems logical to do 30. And of course you already know if you do that, it's 36. And we get 66. So what I like about this strategy is there's not a lot of pressure to like know that there's a kind of a right way to do it. If you understand percents enough to just kind of say, okay, well I know how to do this, I know how to increase something by 20%, then I'm just going to keep trying things until I get my right answer. I'm very comfortable with that. So hopefully that's a strategy that you like as well, a fourth reasonable strategy for you, so that you have all those tools in your toolkit when you see a complicated multi-step percent problem. If you need to go back and see either example again, please do. Otherwise, see you tomorrow.